Okay, we're on. It's been a while since I've been doing a Blockport presentation. What I'd like to do is introduce you to the various melting points of some of the material that I've been using, that I've been actually inserting into the Joe pipe to heat. And what we're actually going to talk on tonight is about the redshift. And if you do a little study into metallurgy or into forging, you'd realize that metal, when you heat it, it starts off as maybe like a straw color, and it builds up to purple and to blue, and it starts changing into red as it gets hotter, and orange, yellow, and white. And anyway, the Joe pipe has the potential to raise all these materials here: titanium, stainless steel, carbon, copper, ceramic, right to the orange point. It's past the red point, between actually red and yellow, but quite a bright orange, as you probably would have seen in the last video. What I'm trying to get at here, somewhere down the road, is that what is that exactly, or how exactly, is the Joe pipe producing heat? And since the process itself is implosion, at least on the bottom end you have implosion here, and you have cavitation here. With that, can I go on to say that if the fire is spinning, is creating a vortex, right? Is it going to produce characteristics which are in line with like Brown's gas or HHO? Just like when you take a Brown's gas torch and see if this was a piece of rock or whatever. You take the torch and the rock would heat up right away. You'd have no problem. It doesn't matter whether it's diamond, carbon, steel, it doesn't matter. That Brown's gas or HHO will heat up to the melting point and even vaporize most known elements or materials. And if the Joe pipe is generating a partial endothermic or implosion spin, maybe this is the reason why it is heating all materials to the orange point, or the orange band, somewhere between 1700 and 1800 degrees Fahrenheit. And you could ask this question: if the propagation or speed of the vortex could be increased, would that have an effect on the burn? Would that raise the temperature from orange to yellow to white? And that's what we're trying to track down, right? And I know in the last test with the titanium pipe, the 1.5-inch diameter by 24-inch titanium pipe, when I put it into the Joe pipe on the vertical test, the outside of the Joe pipe itself actually became more red, more intense, more heat was being produced. And that shouldn't be, because none of the fuel or the air was touched. Everything remained the same. And you could see that it was producing a flame like this, and one of the guys that was there watching it, he was saying, well, it looks like it's burning in the air. So maybe there's more to this, to the inner workings of the Joe pipe. All right, I think we only got a few minutes left here. Well, we can say that titanium melts at 3032, and the steel is more of a hard steel that's being used. So we can say that's melting at 25 55 degrees Fahrenheit, right? And the titanium, well, we did that. The stainless steel, somewhere between 2,500 to 2,650, depending on the grade of the stainless. And copper, we know that copper burns or melts somewhere at just below 2,000 degrees at 1,985 degrees Fahrenheit. Now ceramic, I couldn't get an indication on ceramic, but as they use glass as a coating for ceramic, we can say that it's going to be above the 3,100 mark. Have we got everything covered? I think so. So in the next test, well, what I would like to do is take the titanium pipe, the 1.5" titanium pipe, and insert, have a piece of stainless that's about 1.25" and insert that into the pipe. Then insert a piece of copper. Then inside the copper, I can insert, I got a brand new pyrometer cover for kilns, and haven't used it yet, so I like to put that inside the copper and then put the carbon inside the ceramic tubing, or actually the porcelain tubing, and see if all can be brought up to temperature. It's going to be a horizontal test this time, and see if everything can be converted or brought to the orange band of the transition as far as the heat of the flame goes, right? And just kind of going along by intuition. Now, and I believe as we see steam applied, there was one instance where steam was used, where I was doing a steam test where I took the copper pipe, flattened the end, and I had water on the other end, and it produced the steam, and the steam actually ended up melting the copper that was inside the pipe. So I know that steam can be used to raise the overall energy level, see, from orange up into bright orange and into the yellow state, get more of a yellow-white flame on the hydrogen. So the hydrogen is going to be fairly high end. But what we want to discern or not is the properties, these observations that we're seeing with heating these different metals and elements. Is it primarily because of the induction spin or the vortexing of the flame itself? And if it is, then it should be possible to, by adding steam or adding maybe a geek gas, using geek gas, or using Joe cell stage 3 gas, to bring it right up to the white, into the white band energy. And so by changing out the like a titanium for a ceramic tube, you can actually put different liners inside. That may increase the temperature of the overall temperature of the Joe pipe. Okay, I think I about covered it. I may do a second part of this.